Ever get that feeling, You're walking the floor, everything seems to be humming along, no incidents, knock on wood, and you start to think, hey, we've got this safety thing down.
Yeah, I know that feeling.
But then there's this other part of you, a little voice that says, wait a minute, just because nobody's gotten hurt yet.
It's like a false sense of security almost.
Exactly. And that's what we're diving into today, presence sensing safety systems for machinery.
Absolutely. We're lucky today because we've got some really fascinating material from PowerSafe Automation. They really get into all sorts of engineered safety systems, but what really stood out to me was their focus on these electronic safety devices. They're like intelligent guardians watching over everything.
Right. And for everyone listening, that's what we want to unpack today, all these different presence sensing technologies. What do they actually do? How do they do it? And most importantly, how do they actually make your work environment safer? And don't worry, we'll keep it clear. We're not going to get bogged down in the weeds.
No jargon overload today.
Exactly. So let's jump right in. First up, safety light curtains. When we say safety light curtain, what exactly are we picturing?
Okay, imagine like an invisible wall, a force field almost.
Oh, like in a movie.
Exactly. That's essentially what a safety light curtain does. You've got brands like Keyence and Allen Bradley leading the way here. They project these beams of light across an opening, around a dangerous spot. And if anything, break that light curtain, like a hand, a tool, whatever boom machine stops.
So trip the light, fantastic, and it's not so fantastic.
You got it. Safety first.
Now, the material we're looking at talks about standard light curtains, ones with blanking, and something called muting. What's the difference?
All right, so standard, that's the simplest. Break the beam, machine stops, no exceptions. Blanking is a bit more specialized. It lets you block certain parts of the light curtain, and the system is programmed to just ignore those spots. Think of it like if a piece of the machine itself needs to stick through the curtain, you can blank that area out.
Ah, so it knows to ignore that specific spot all the time. Got it.
Exactly. Now, muting, that's a whole different ballgame. Muting is temporary. Say you've got a robot arm loading parts. When that arm swings through the curtain, you can temporarily mute the system so it doesn't stop everything. But as soon as the arm moves out, the safety function kicks right back in. It's crucial that this is carefully set up. You don't want to compromise safety during normal operation.
That makes a lot of sense. Now, I noticed they also mentioned these systems coming with cables, mounting brackets, and relying on safety controllers. There's even talk of redundancy, manual resets, automatic resets. Why is all that extra stuff so important?
So redundancy, it's not just about having a backup. It's about making sure that if one thing fails, the entire system doesn't go down with it. The safety controller is constantly monitoring everything, looking for problems. If something goes wrong, that redundancy kicks in and the machine stops safely, reduces the chances of something slipping through the cracks.
So it's like a double check, a safety net for the safety system itself.
You got it. Now, as for manual versus auto reset, it's really about what happens after the curtain's been tripped. Manual reset means someone has to physically go there and restart things, which is common when you need to figure out why it stopped in the first place. Auto reset, the system just restarts itself once the obstruction is gone. That's usually used when interruptions are expected and not a big deal safety-wise.
Makes sense. So light curtains are great for these flat, invisible barriers. But what about bigger areas, more complicated shapes? I'm guessing that's where safety laser scanners come in?
Bingo! Safety laser scanners. We see Keyence mentioned here again. Instead of a solid curtain of light, these things emit a laser beam that constantly scans a 2D area. We're talking a range of up to 27.5 feet in a 190-degree radius.
You can actually program a custom safety zone on the floor.
So it's like a laser tripwire, but you can shape it however you need.
Pretty much. If anything steps into that zone, the scanner picks it up and bam, stop signal goes out through a safety relay. And I see here that these are generally tougher than light curtains when it comes to dust and debris, which makes sense in an industrial setting. Plus, some of them even have cameras built in.
That's right. It's interesting you're getting a safety device that's also giving you operational data.
Yeah, two birds with one stone. So you're monitoring safety, but you can also get insights into traffic flow, maybe even identify potential bottlenecks that could lead to problems.
Exactly. Sometimes you get these unexpected benefits from safety tech. Safety's the main thing, but getting extra data, that's a nice bonus.
All right, let's up the ante even more. Now we're talking 3D safety radar, specifically the InchSpec system. This sounds like it adds a whole other dimension, literally.
It does. InSpec uses this multi-zone radar tech. You've got the smart sensor and the dual-channel controller. Think about it. Laser scanners are working on a flat plane. This thing creates a 3D detection zone, almost like a bubble. We're talking up to 9 meters, 100 degrees horizontally, 20 degrees vertically. It's a much more sophisticated way of monitoring.
So with that 3D capability, you can do some really interesting things. The material mentions things like multiple stop behaviors depending on where a person is, preventing automatic restarts if someone's still in the danger zone, even stuff like anti-collision for vehicles.
Yeah, anti-collision, that's a big one, especially when you've got a lot of moving parts. And it's super sensitive. It can pick up something as small as a human limb at extended ranges using radio signals.
Pretty amazing, but every technology has its limits, right?
Absolutely. The information points out some important limitations with radar technology. Dust, metal chips, fog, oils, water, rain, even metal shavings, all those things can mess with it.
Right.
And it might be more likely to pick up big objects first.
So you really have to understand the environment where it's going to be used.
Exactly. They talk about doing feasibility tests, which makes a lot of sense. You need to know it's going to work reliably in your specific setup.
Right. Every situation is different.
Right.
Okay, let's switch gears a little bit. We've talked about these really high-tech sensing methods, but now let's talk about something that might seem simpler, but is still absolutely crucial. Safety switches.
Right. Back to basics.
The information focuses on Allen Bradley non-contact switches that use this RFID technology. Why is that a big deal?
Think about your typical safety gate. A lot of times they use magnetic sensors, but those can be tampered with, you know? Someone could slap a magnet on there and trick the system. These RFID switches are way more secure. They need a specific coded signal, plus they're not as picky about alignment.
So a door being a little bit out of whack won't cause a shutdown.
Right, it's more forgiving. Doors can shift over time in an industrial setting. And of course, these switches are all hooked up through a safety relay to get that high level of reliability and fault tolerance that we were talking about earlier.
Safety category levels, right.
Yeah.
Could you refresh our memory on what those mean exactly?
Sure, it's basically a rating system. Higher safety categories mean a more robust and reliable system, one that's better at catching faults and preventing accidents. So those RFID switches connected through the safety relay, they give you that extra peace of mind.
That makes sense. And these switches, they're often hooked up to emergency stops or used to trigger controlled stops with dynamic braking. For folks who aren't familiar with that term, what does dynamic braking actually do?
Think of it like anti-lock brakes, but for a motor. Instead of just cutting power and letting the motor coast, dynamic braking actively slows it down really fast. This can be a lifesaver in an emergency when you need things to stop now. And the nice thing is, these switches usually come as a complete kit. Cables, brackets, tamper-resistant hardware. Makes installation a breeze.
So you're not hunting around for extra parts. It's all right there. Now, what about those situations where you absolutely need to make sure a door stays shut until the machine is totally stopped? That's where door locking safety systems come in, right?
Right again. The information highlights a Keyence safety interlock switch that actually uses RFID for the locking mechanism.
Oh, that's interesting. So how does that whole system work?
Okay, so imagine this. An operator needs to get into an area with moving machinery. They send a signal to open the door. But here's the key. The door won't unlock until the machine confirms it's at a safe stop. That confirmation can come from all sorts of places.
Oh, so it's not just a simple timer?
Not at all. You could have something like an Allen Bradley back EMF monitor relay that looks for residual voltage in the motor, or an amp clamp sensing current. You can even have signals from PLCs, safety encoders that watch the motor speed, even timer-based circuits managed by a controller. And that RFID tech in the Keyence switch, that just adds another layer of security, makes sure the lock itself can't be tampered with.
So it's a multi-step process to make absolutely positively sure that machine is safe before anyone can get in there.
Precisely. Safety first.
Now, for a completely different approach, let's talk about safety switch mats. These seem pretty simple, right? You step on the mat, something stops.
On the surface, yes. But there's more to it than meets the eye.
I bet there is.
So the basic idea is pressure. You step on it, you trigger a response, usually an emergency stop. Some of these things can pick up as little as 15 pounds of pressure. But the real engineering is in the design and how they're integrated. The material mentions brands like Recora Safety, ASO Safety, Pinnacle Safety. They all make these mats with redundant wiring, that dual lead thing. That's an extra safety measure in itself.
So if one wire fails, the other one's still there.
Exactly. And the cool thing is they're incredibly customizable. You can get them in all sorts of sizes, shapes, materials. Need one that can handle chemicals? No problem. And they have these trim kits, so you can bolt them down securely, no tripping hazards.
Smart. You wouldn't want to create a hazard while trying to prevent one.
Of course not. And just like a lot of these other electronic devices, safety mats are designed to work with a specific Allen Bradley safety controller. It's
Mm.
all about integration.
It's all connected. Okay, now this next one sounds really cool. It's called the Allen Bradley Trapped Key Interlock Safety System. And it's described as more of a safety infrastructure. It relies on a specific sequence of keys and locks. How does that work to keep things safe?
Okay, trapped key systems, they're a whole different approach. It's like a physical puzzle you have to solve before you can access a hazardous area.
A safety escape room, sort of.
In a way, yeah. So first, you need a key to turn off the power, the main hazard. That key then gets trapped in the disconnect switch. Now, to open the access gate, you need either that same key or a series of other keys released in a specific order. And because it's mechanical, it's super reliable, minimal wiring, no complex electronics to fail.
Elegant in its simplicity.
Absolutely. And you can configure it in all sorts of ways. Single operator, multiple users, even deadbolts if you need them. It's really flexible.
So it's forcing you to follow the right steps in the right order. No cutting corners. Okay, we've covered all these different present sensing devices, from high-tech electronics to good old-fashioned keys and locks. But as we've touched on, they don't work in a vacuum, do they? We need to talk about the brains of the operation. The monitoring devices, the safety relays, the controllers, the PLCs. What makes those so vital?
They're the unsung heroes, really, especially when you're dealing with all these electronic safety devices. Their main advantage is fault detection. Unlike a standard relay or simple switch, a safety relay, a controller, a PLC, they're constantly monitoring themselves and everything connected to them. If there's a problem, they know it.
They're like the watchdogs of the system.
Exactly. They're looking for things like broken wires, component failures, anything that could compromise safety. It's a huge step up in reliability.
So they add a layer of intelligence to the whole safety setup. Now, to make sure everybody knows what's going on at a glance, we've got indicator stack lights. We've all seen those towers of colored lights on machinery. What do the different colors usually mean?
Stack lights are all about communication. They give you that instant visual and sometimes audible feedback on what the machine is doing. You'll see them right on the machine, or maybe on a nearby control panel. Green usually means things are running smoothly. Yellow is like a caution signal. Red is a stop or emergency. And then you might have blue or white for custom signals. A lot of them have buzzers too, so you can't miss it.
Can't miss those.
Yeah.
Especially the 120 decibel ones.
They'll definitely get your attention. The information mentions using them with laser scanners and 3D radar, which makes sense. You want to know right away if those zones are clear or if something stripped them.
Clear and immediate feedback, that's what you want. Speaking of making things easier, the material mentions these pre-configured power controls safety enclosures. What's the advantage of going with one of those?
They're all about simplifying things and reducing the chance of errors during setup. Everything's pre-wired, power supply, safety relays, controllers. You just connect your safety devices, light curtains, switches, scanners, and you're good to go.
So you're not spending hours poring over wiring diagrams.
Exactly. Less chance of making a mistake, too. And they come with schematics, so troubleshooting is way easier. It's a really streamlined approach for common machine guarding setups.
Plug and play, but for safety. And I see there are also custom-built enclosures. When would you go that route?
Custom enclosures are for those unique situations where you need something really specific. Maybe you want each individual switch monitored or really granular control. You might need to integrate pneumatic components or have extra emergency stops, special stands, cooling systems. It's about matching the safety system perfectly to the application.
So when off the shelf won't cut it.
Right. And just like the pre-configured ones, you get all the schematics, so everything is documented.
So whether you go pre-built or custom, it's all about having the right level of safety for the job. Well, we've covered a lot of ground here today, from light curtains to trapped keys, all the way to the monitoring systems that keep everything running smoothly.
We have. It's really been a deep dive into the world of present sensing.
And the key takeaway for everyone listening is this: don't wait for an accident to happen. Just because everything seems fine now doesn't mean there aren't risks lurking around the corner.
I couldn't agree more.
We've talked about all these tools, these engineered systems that are designed to prevent accidents before they happen. 3D radar, safety mats, trapped key systems, they all have their place.
And the technology is always evolving. It's amazing what's possible today compared to just a few years ago.
That's a great point, which brings me to a question for everyone listening. Thinking about your own workplace, are there any risks that you might have accepted in the past, things you thought were just unavoidable?
It makes you wonder, are there risks we're living with that we don't have to? What could we prevent with the technologies we have now?
That's something worth thinking about. And if you want to learn more about any of these technologies or you're not sure what would be best for your specific needs, reach out to the experts at PowerSafe Automation. You can find them at 129 North Main Street, Wolcottville, Indiana, 46795. Or give them a call at 844-520-7233. And don't forget to check them out on Facebook and LinkedIn. Thanks for joining us for this deep dive.